What is up everyone, Nick here, and in today's video we are going to be checking out the latest 3D printer from Anycubic, the Kobra X. The Anycubic Kobra X is a next-gen desktop 3D printer focused on fast and efficient filament changes for multicolor 3D printing, featuring Anycubic's new Ace Gen 2 system, which allows for built-in filament changes of up to 4 different filaments without the need of an external multi-material unit. The Ace Gen 2 system was specifically designed to significantly reduce filament purge lengths during filament changes, saving both time and material compared to previous Anycubic multicolor systems. Now I should mention that Anycubic did send me this model for free to feature in my content, however all thoughts and opinions are entirely my own. And this is also a pre-production model, meaning that some features may not be fully implemented yet, and there might be some changes to the final appearance of the Kobra X once it actually releases. And speaking of which, the Kobra X should be available in March, and as of the time of this video, early bird sales for the Kobra X are currently live, so make sure you check out the links in the description to get yours now. So before we get to unboxing and 3D printing with the Kobra X, let's quickly check out its features and its specs. It's worth highlighting that the Kobra X puts a huge emphasis on saving time and reducing filament waste when 3D printing multicolor prints. And in my own testing, I timed a full filament swap from start to end in about 60 seconds, which is noticeably faster than most other bedslinger style 3D printers that rely on external multi-material units for multicolor. Speaking of which, the Kobra X not only saves a lot of time when doing multicolor prints, but it also saves a ton of filament waste. And this is because of the super short filament path between the Ace 2 Pro and the actual hot end. To compare, I 3D printed an identical multicolor benchy on the Kobra X and on the Bambu Lab A1 combo. And I did this using the exact same filament profile, as well as the exact same multicolor 3D model. Now with the A1, it took about 12 hours to 3D print, and it also wasted about 161 grams in purge filament, and then another 25 grams for the prime tower and 10 grams for the benchy itself. Meanwhile, the Anycubic Kobra X was able to print an identical benchy in 6 hours and 50 minutes. And this only wasted 76 grams in purged filament and another 25 grams for the prime tower and 10 grams for the benchy. So that is about half the time and half the wasted filament using the Anycubic Kobra X compared to most bedslinger 3D printers with a multi-material unit. And on top of that, you can actually use up to 19 different colors on this machine if you use additional Ace 2 Pro systems. And it also features a 260mm cubed build volume, which is slightly bigger than the Bambu Lab A1, and supports materials like PLA, PETG, TPU, PVA, PLA-CF, PETG-CF, and according to Anycubic, ASA as well. In terms of performance, the printer is rated for 300mm per second recommended print speeds with a maximum speed of 600mm per second, along with recommended accelerations of 10,000mm per second squared and a maximum of 20,000mm per second squared. Now the real star of the show is Anycubic's Ace 2 Pro technology, which the Kobra X is essentially built around. It's basically a filament changing unit and an extruder built into one and put into the Kobra X's toolhead. When compared to the Kobra 3 V2, the Ace Gen 2 dramatically improves color change efficiency by reducing the filament retraction distance from 160mm down to just 30mm. Anycubic also claims 40 to 50% less purge waste during multicolor printing, thanks to the redesigned filament switching path. And thanks to its new switching path, the system is also designed to support soft to hard and soft to soft multi-material printing, making it more versatile for complex parts and functional prints, which we'll talk about later. So now that we've talked about the Ace Gen 2 and some of its features, we're gonna get down to the nitty-gritty when it comes to this machine's specs. The hot end is really cool since it's actually a quick release design. Included with the printer is a 0.4mm nozzle, but you can easily change it to 0.25, 0.6, and 0.8. The hot end is able to achieve 300 degrees Celsius, while the print bed can reach 100 degrees Celsius. The Kobra X also comes equipped with LeviQ 3.0 auto leveling, giving us a 49-point automatic bed leveling with no manual compensation needed. And it can also level specific build plate areas used when printing to reduce the time it takes to probe the bed. On release, the Kobra X will also have real-time flow dynamic calibration along with vibration compensation and pressure advance. In terms of smart features and monitoring, the Kobra X has a 720p camera with real-time AI monitoring for detecting foreign objects and failed prints, plus the ability to skip objects as well as auto resume and auto recovery after power loss. When it comes to 3D printing, printing, you have the option to send prints from the printer interface, the slicing software, the Anycubic app, or via USB. As far as firmware goes, the Kobra X runs on Kobra OS, and it's compatible with Anycubic Slicer Next, which is Anycubic's own slicing software for preparing 3D models for 3D printing. And last but not least, the Kobra X has active noise reduction, with under 48 decibels standard and under 45 decibels in silent mode. So now that we've covered all the listed specs of the Kobra X and what makes it so intriguing, let's get to finally unboxing and 3D printing with the Kobra X. The unboxing and assembly process was super smooth. All I needed to do was remove all the zip ties and foam, keeping all the parts secured for shipping. And one detail I really love is how the X gantry attaches to the base of the 3D printer. A lot of bed slinger 3D printers, or at least the ones I've used before, would require you to rest the gantry and base on its side so that you can screw them together from underneath the machine. Instead, you actually screw both halves together from the top, and once it's bolted together, you just have to insert these covers to keep debris from winding up in the path of the bed as it moves. As I was getting my Kobra X set up, I did forget to connect a few wires for some of the motors, so after a few error screens and double checking all the connections, I figured out what I did wrong, and I was able to move on to calibrating the Kobra X, which included PID tuning, vibration compensation, and leveling the bed. One thing I did find interesting is how the tool head and bed continue moving side to side as it completes its vibration compensation. On all the other machines I've ever used, these stay stationary. Just something I felt worth noting. So with all that setup done, now we can actually move on with 3D printing some stuff with the Kobra X. So I started by 3D printing the pre-sliced files that were already included with the Kobra X, like this multicolored bottle opener. And it turned out pretty good. There is a slight elephant's foot, but the surface quality is really good, and the top surface layer is pretty nice if I do say so myself. Afterwards, I went ahead and 3D printed some more of the pre-sliced files, like these two benchies. Anycubic included two differently sliced benchies, one intended to showcase speed and the other for quality. I 3D printed the 14-minute benchie first, and the quality left a little bit to be desired. For example, the text on the back is completely unreadable, not to mention the surface quality being a bit off, and the holes in the top layers from the low wall counts and low infill. It's still really impressive that a bed slinger was able to pull off a benchie in just 14 minutes, especially since the overhangs for the hull didn't really curl or anything, so it's definitely not the worst benchie I've ever seen. The second benchie took about 40 minutes and is a lot nicer. The text on the back is readable, there are no gaps in the top layers, the hull line is barely present, and the surface quality is just generally a lot better from the first one. And I also 3D printed this pre-sliced flexi-rexy, and like my other prints up till now, there seems to be a slight issue when it comes to the Z offset. Like, don't get me wrong, the bed adhesion because of the Z offset is really good, but it's slightly too close to the bed. So the print turned out really good, but the brim that was included in this print was super hard to get rid of since it just fused itself to the flexi-rexy's tail. I also 3D printed the spider, and honestly, there's not a lot to say. It's a static print, and the print quality is really good, so no complaints here. And lastly, when it comes to the pre-sliced files, I also 3D printed this first layer test. It's exactly one layer of filament across the entire volume of the print bed. This print not only showcases the print's adhesion, but also how well tuned the Z offset is. And as you can see, there are no visible indications that the printer is printing too high off the build plate since there are no gaps. However, along the corners, there are signs of the layers being squished too hard against the build plate, which is what causes these rough patterns in the first layer, which is not ideal, but hopefully this won't be a problem once the printer actually launches and the mesh bed leveling works a little bit better. But I do want to mention that while editing this video, Anycubic did send over a firmware update for the Kobra X along with an update for their slicer software. So I resliced and reprinted the XY layer test, and it is a lot nicer than the first one. There's practically no imperfections across the entirety of the build plate, which is quite nice. Now past this point, I started slicing my very own 3D files using Anycubic's own slicer software called Anycubic Slicer Next, which is a rehash of Orca Slicer and Bamboo Slicer. Right out the gate, I went for the hardest 3D prints I could possibly think of to really test out the Ace 2 Pro and see how it really handles multi-material printing, specifically to see if it's really able to 3D print both PLA and TPU in the same prints. So that's why I 3D printed this set of pliers. So the red that you see here is actually PLA, but in the center is a black piece which is 3D printed out of TPU, which gives it the ability to have a living hinge within the print. And this living hinge is what allows the pliers to actually be able to open and close. Now, since PLA and TPU don't exactly bond together that well, this 3D model uses a mechanical connection to lock the TPU and PLA components together so that they don't come undone. And honestly, the Kobra X absolutely nailed it. No jams, no clogs, just a finished 3D print on the first try. And on top of that, it came out pretty good. Now, this isn't exactly a useful set of pliers, but it does actually showcase how a living hinge would work in an actual use case and how you can actually 3D print that using mechanical locks within your 3D print in multi-material. And just to make sure that this wasn't a fluke, I went ahead and 3D printed a different set of pliers using a different 3D model. And I got the same result, a functional 3D print with no clogs or jams despite switching between TPU and PLA throughout the print. I also 3D printed this multi-material test by Rainer WP, which uses TPU to hinge these PLA pieces so that they flex and reshape around each other. And this also successfully printed on the first try with very minimal purge waste since the TPU and PLA were only used for a handful of layers. And just so I could showcase in this video a 3D print that wasn't necessarily multicolor or multi-material and that used the vast majority of the build plate, I went ahead and 3D printed this Kanohi Evoki from Bionicle, the Mask of Light. And this was 3D printed out of a gold silk PLA, just using the standard presets available in Anycubic Slicer. And it turned out pretty good. It took about 12 hours to print, and all the supported areas and overhangs came out really clean. Although the consistency of the shine leaves a bit to be desired, and that could be something Anycubic could look at tweaking in the slicer prior to the printer's official release. And once again, while editing this video, I tried reprinting another silk PLA Kanohi mask from Bionicle using the updated firmware and updated slicer software. And this one came out a lot better. The shine of the surface is perfectly consistent across the entirety of the print, and I'm really glad that Anycubic is actually tweaking these things before the official release. So in conclusion, I'm actually pretty blown away by the Anycubic Kobra X. It's a fully competent 3D printer in its own right, and on top of that, it comes with a built-in multi-material unit in the base model, which is capable of handling TPU, which has been the biggest gripe with a lot of multicolor filament units on the market up till now. And if that weren't enough, it's being sold for a remarkably reasonable price. Right now, from January 15th to February 28th, you can take advantage of Anycubic's early bird sale for the Kobra X, which is available for $279 USD or $390 Canadian. And even at an MSRP of $399 USD, this is still a pretty good value for a 3D printer that has a built-in multi-material system, which up until now has still been insanely reliable for me. So if you're interested in picking one up yourself, I'll leave affiliate links in the description. And if you have any questions about the Kobra X, please feel free to leave them in the comments down below. And that has been my initial thoughts and experience using the Anycubic Kobra X. If you like what you saw, please make sure to hit that like and subscribe button, and I will see you all in the next one.